Hello everyone, we are ShallowLearning. Our project is Hidden Fashion. Our task is based on Deep Fashion 2. This dataset contains 491,000 images of 13 popular categories and has richer annotations compared with other existing datasets. Unlike previous work that is working on the image level, this dataset contains multiple items present in one single image. Our goal is to help improve the performance of fashion image analysis in real-world applications. We collect data by controlling the variations in terms of four properties as shown in the figure. And we have three main tasks: landmark estimation, class prediction, and close retrieval. We made several attempts for this data challenge. We first tried VGG 16 and 19 in the midterm, then transferred to the MobileNet v2. Finally, we re-implemented MaskRCN as baseline model and made several improvements. We proposed our model, MagRCN. Here's the overall architecture. The model is based on MaskRCN with additional key point and flip channels. The first stage is feature network, which is composed of the ResNet 101 and feature pyramid network. Each time, we feed a pair into the ResNet, and then the FPN uses a top-down architecture with the lateral connections. ROI Align extracts features from different levels of the pyramid map. In the second stage, Perceptual Network contains three streams of network as shown in the figure. It jointly learns the three tasks, which demonstrates extraordinary efficiency. The object function is to minimize the four loss functions, which are formulated as above. We use cross-entropy for class, key point, and mask, and a smooth loss function for bounding box regression. Unlike the baseline model that employs the ResNet 50, here we use the ResNet 101 instead to extract features. Originally, we tried the lighter weight MobileNet, but it turns out that it would suffer from its classification, especially for those clothes that have high color contrast. Therefore, we used ResNet 101 instead. Although more parameters are required, it is still much lighter than VGG. To further control the model scale, we resize the image to the longest edge of no more than 1024 pixels. Additionally, we magnify the key points and perform standard data augmentation with random horizontal flipping. This helps draw a clearer boundary of the landmark. Finally, we jointly learn the framework of the three tasks using different streams and aggregate them at the end. This significantly improves the accuracy. It turns out that the MobileNet v2 performs worst. VGG 16 and 19 performs a little bit better, but still have a loss near 1. Mask and Mag, on the other hand, perform well on this task. One of the interesting is that MagRCN outperforms MaskRCN in the mask task. We guess it is because we add the key point in our model. We also find that the classification error is higher than the baseline. Therefore, we conducted an error analysis. We randomly selected 100 images and classified each error into different categories. We find that clothes like jumpsuits or images that has complex pose are easily misclassified. This is just the process about how our model retrieves the clothes. Here are the same clothes pairs from either buyer side or seller side. Above is from the shops. The below one is a real customer try-on. Here, top K retrieval accuracy is adopted to measure the performance of retrieval task. It turns out that the MagRCN improved the model accuracy by 3.66%. To conclude, we propose MagRCN to classify the clothes and realize a close retrieval. For further improvement, we will consider applying graph reasoning network to address the misclassification problem, and hopefully realize one-click dress-up change. That's it. Thank you.